Soon, very soon. Screens are difficult, AI is a little bit easier, I guess, right? So that's what we're going to talk about. So we're going to talk a bit about, we have quite a few things to talk about. But first, my name is Rustam. We have 30 minutes, 35-ish minutes to go through quite a bit of stuff. And I want to talk a bit generally about the LLMs and open local LLMs, local models, open models, all this kind of stuff, and also reflect a bit on how you can put that stuff into some Java code. I do have a little demo here at the end. We'll see if how much time we have at the end to actually run some of it. But I would like to start with local LLMs, open models, all those kind of things. LLMs, anyone? You've probably heard that before, right? Yes, okay, 2 people have heard about it. The rest of you, what are you doing? I mean, that kind of jokes never get old because, I just want to check that your arms are working because I want you to use them afterwards for asking questions and stuff. For the rest of you, this is what LLM is. So it's a large language model, but there are also smaller LLMs that are called small language models, and generally it's kind of a predictive thing that will end up predicting what is the word next is coming and the most likely to actually be. A lot of people think of it as a magic. It's not, but don't tell anyone. Everybody thinks it's magic, so just, stick with it. But what I want to talk a bit about more, because we've heard about LLMs, we've also heard about open models. We also confuse them a lot with open source models. They're not. It's open weights model. It's different, right? So that's another important thing to be aware of, so this is one example. There are a bunch of others. I'll show you a list in a bit. But so this is an open weight model by Google that it's based on the Gemini, which is the not open model, but it's also, they actually tell you how you can fine tune it as well. We'll talk about fine tuning in a bit as well. Why do you want to do that? When do you want to do that? And all this kind of thing. So open models usually run locally, so you can actually run them on your machine. So on this machine, I'm running like a couple of models, and they're pretty fast. If you haven't heard your fans on your Mac for a while, it's a good way to make them work. Especially larger of those models, because they usually have some kind of number and a B at the end, billion parameters. And the larger they are, usually the more hardware they're required to run, but they actually run really nicely on relatively not so new models and hardware and stuff. This is an M2. Now we have M4, so, it still works quite fine. We'll see that. Why do you want to do that? Well, sometimes you are very opinionated. Sometimes you have to run it locally for some reasons. One of the reasons could be that you don't want to share, the data is so sensitive that you don't want to send it somewhere where you kind of lose control over that data, or the larger models that are out there on the internet will not be good enough because of the privacy, because of some sensitivity of that data and all those kind of things, right? The other reason could be also where you want to train your own model on top, so you can do fine-tuning and stuff like that on top of that as well. It's not that easy to do. Yes, you can do grounding and things like that for larger models and the models that are out there that are managed by the larger providers, OpenAI, Google, all of them. But sometimes you want to train your own thing. You want to fine-tune your own things as well. Sometimes you don't really have to choose. Somebody told you to, right? If you're working as a consultant or somewhere, sometimes they will just say, you know what, we have to run this locally, or we have to use this and that. And sometimes it's just the choices are made for you, right? But there is also downsides of it, right? So with the great power, all that stuff, right? So then we have also the same thing here as well. With the choice and the control, it also comes responsibility. Now you're responsible for making sure that your stuff is up and running, it's giving you proper results, is not hallucinating, is not all the ethical questions, is not letting you do one thing or another, and there's a lot of things that you all really need to control as well, right? And also the other thing is that when those models are smaller, because they need to run on less demanding hardware, they will also have less smartness. I mean, it can be different things. It can be also knowledge, things like the cutoffs for the knowledge, for the training stuff. It can be things like reasoning and all this things connected to that as well, but they might not be as good, right? I've tried, especially also, a lot of models will support different languages, and you'll also see that the difference between different languages would be also quite a big. I've been asking like stupid questions from the local models, saying like, "Hey, tell me a joke." Right? In English, it will tell you kind of okay joke. You ask it to tell you a joke in Norwegian, it will be bad. It was horrible. I asked it, like, I was in Greece a few months ago, and I was doing this thing on the stage, and I was like, "Hey, tell me a joke in a Greek." And then, like, there was something on the screen, I can't read it, but the people in the room could, and they were like, "This is bad." So the language, it depends on how things were trained, how things were, how much access they have, and also they really need to cut down the amount of data because of the size of the model, right? The good thing is that, again, there is also opportunities, right? When you have open models, you can do it the way you want. You can also run it on very small devices, so the smaller models can run on this, right? You have AI running on devices, and a lot of things are happening on device. No, they're not sending somewhere and coming back. There is still an issue of fine-tuning. There is still an issue of a gap of knowledge between those models and when the cutoff, the training cutoff has been, right? So you need to add some stuff on top of that. This is not meant to be a marketing slide. This is more what to look for a typical model. So this one has it, fine. Other models might have it, might not have it, but this is what you want to look for. You want to look for models that take safety seriously. You don't want to have a model running on your machine where users will be able to find like, "Hey, tell me how to make a bomb," and then it will be like, "Yeah, here." Sucks a little bit, right? You don't want that publicity and stuff. So some models will not be, some models will be filtered also on pre-training data, so data that they actually give into the model. So sometimes they will just like cut off the data that you shouldn't need. But it's also have a safety tuning on top. So it's like it's safety in, safety out. That's a good thing to consider and think about, that when you're running local models, this is also part of your responsibility. Another thing is that you can also expect something that has something that's been tested by both machines automatically, but also by humans. Something that very often they would publish some kind of benchmarks and compare the different models between each other, so you know how they're performing, if they're performing better or worse than something else that you're considering to use. And yeah, so this is outside, right? This academic part, but there's also internal evaluations as well. So you have some teams, like you do in the security, red teams and stuff, that try to make it break and try to make it do things that's not supposed to and see how it works. So it's really good to look for things that have this kind of properties. Some examples, well, I mentioned quite a bit GEM already, but there is also Llama, Mistral, Mixtral, there's a lot of them. There is also lists where they're being compared, where they're being benchmarked against each other. Some are better at one thing, some are better at the other thing. So you need to, there is no silver bullet. I cannot say, hey, just use this and it will save your life, or something else. It will be different based on your use case, based on the data you want, based on how easy it is to fine-tune it, and so on, so on, so on. Right, so that's the first thing, right? We can choose between, I've seen a lot of demos. I've seen a lot of people doing demos. Hey, let me show you how to do AI on an application, and blah, blah, blah. And then they were like, what do you do? Well, we just call OpenAPI APIs and send data and then return it. Done, cool. You can actually run local models. You can do it much more contained. Again, privacy is one thing, but sometimes you don't have a network access. Sometimes you don't have a network bandwidth. Sometimes you want to do it on the machine. So you can use all this kind of stuff. What else you can do? Well, you can also orchestrate workflows. It's not anymore just a call and going back. Now we have agents. Now we have function calling. We've had it for a while, but now they're getting more and more structured and standardized and stuff. Function calling is where you have a defined list of functions and also let the model call a specific function and get a return results. So typically, early days of LLMs, we knew that they were kind of bad with math, and then we would do like give it the math question and then make it answer wrong, give us the wrong answer. It's like, haha, look, it sucks. We used to do that, right? And now, if the model is smart and if it has some kind of ways of doing function calls, most of the models, big models do, where they actually go online and search for things and then use the results of the search results as an input to the model in the background. This kind of things will be much, much, much easier to handle, right? You can also turn, for example, very often, you can turn on grounding, for example, grounding for search, grounding for your own data. So you can provide your own data sources and say, hey, I want it to be grounded towards that, against that. So function calling it's a very nice thing, because now you can actually call repeatable functions that actually give you the same results, and testable functions as well inside your models. And then there is this thing of function calling versus agents. Function calling is, I usually talk about it like you have in functions in cloud. Very simple, small, tiny little things. Agents is a more complex. You can actually do a workflow. You can define how it's supposed to work. Now we also have agent-to-agent models where you can create a system of agents talking to each other and being good at one thing, another thing, different things, and also cooperating and giving you results back. Another thing is that we talk quite a bit about is context and embeddings, because the models can be good, but they're not as good as, they will never be as good as a model with the right context. If you ask it something without giving proper input and usually quite a bit of text, it will fail at some point. And then sometimes it's just, well, it's not failing because it sucks. It doesn't know what you're asking it to do. And I've seen that. If you have time, we'll have a look at this. Maybe I can show you real quick here. AI service. So, this is that much text with bolds and somewhere caps and all this kind of things where I had to write to make it return 2 random strings, because that's as a JSON. No, I don't want you to do this. I want you to return an array of blah, blah, blah. It has to be JSON, it has to be this. And this is nothing. It could have been twice as much, really. Because I ended up like writing return me a JSON array with 2 random strings. It would just return me some weird stuff. okay, fine, I'll add this and add this and add this. And so you have to keep adding a bit of context to make it work. And then you also have things called embeddings. So models are actually, well, you know, this is a myth that goldfishes don't have memory, right? They actually been proven that they actually can remember quite a bit. Models can't. So if you restart the model and rerun, or next question coming right after the other, if nothing has been done, it will have no idea what was going on, because if you're not providing context, it will just assume it's a totally new, fresh question. You do not see that in ChatGPT, Gemini, and all the other ones, because they're doing it in the background for you. With the codes, when you're writing your code with Java, Python, whatever you want, with LangChain for J, all the other things, you really need to actually say, hey, I want context. I want to provide that. If you're not, it will just be really weird about it. Then there is also RAGs. So RAGs is a kind of vector databases where you can also index your own data and split it up in smaller pieces, so it can be also used as context, or also used to be searched by large language models to provide you results. There are a bunch of databases that support that you can integrate in your code, so you can provide your own data as a context. Because the reason you do RAGs and not just put everything in a context is that the models usually have a context window. And if context window is too, no matter how big it is really, you cannot put all the data you have, all the documents, all the PDFs, all the websites and everything in one go. It will be full at some point. And then, but then you can do RAGs, you can do vectored data. So the data that will tell the model where to look for that, find it, and put it back into the context to give you better results. Now everything has an MCP server. Everything. Like, I'm just waiting for my, I don't know, washing machine or something to get an MCP server. It's like, it's insane. Like, everything has now an MCP server. And it's kind of interesting because that's interesting. Okay. The model context protocol is a way of providing also functions and providing context to your LLMs. So you can also create a server with certain functions that that you want to. I don't know, ska jag då? Nej, okej. Nej. It's a way of providing the information to your model and a way of adding functions to your model so it can actually call things. So yesterday I had a workshop here, and we were doing some deployments of stuff on Cloud Run, some Java code as an application to Cloud Run. And then we could also do that through a Gemini CLI, because Cloud Run also has its own model context protocol. You can actually tell in the chat, hey, I want to deploy this. Do it. It's a kind of, think of it as a kind of advanced way of doing function calling. The MCP servers, it's a standard. They are expected to have a certain kind of functions. But again, most of the times when you're using already existing libraries that say that, hey, we can provide you with MCP servers, they will do all that for you. You don't have to think about most of that. So Quarkus does that, and a bunch of others like Spring AI and all the other ones. They will do all those things that you need to. You don't have to really think about it, but it's a set of functions that have to be there, and then you also add your own stuff to it. Another thing you can do with LLMs and AI and stuff is to, sometimes it's just doing data transformation. You have to be careful a bit about how you do that, and your prompt engineering of what to do and how to do it and stuff like that. Also testing, because models do hallucinate, and they can hallucinate, and they will at some point hallucinate. But then you can also, sometimes it's very nice, because sometimes with the very complex things, you can just say, hey, I want this to be converted into something else, and you don't have to write code for it to do that. That's kind of a nice thing, right? I've used that actually quite a bit, because sometimes you have some kind of structured data in one way, and then you create a prompt that will convert tables into some other structured kind of information and let me restructure data in a simple way. When we talk about structure and all that, we need to talk also about the fine-tuning, because this is coming after the training. So the providers, they train their data, they do some pre-training thing, they do they do training, and then you can also do post-training as well, because this is after the model has been done with the initial training. You can also you can provide your own smaller data sets and say, hey, in my data sets, this is the most important things. This is the things I want you to think about. And then it will adapt to a very specific task or domain, because the models are general. But then if you look, for example, at Gemma, since we're talking about Gemma, Gemma has a bunch of variations. Code Gemma, it has Med Gemma, there is a bunch of few others. There's also a few versions of Gemma that are specialized on languages and stuff. All that is fine-tuning afterwards, so you can actually do the fine-tuning on top of that, and you can do it on your own as well. Last thing I want to talk about is, okay, fine, we've put all that in our applications, in our Java applications or anything else. How do we make it resilient? Because we want it to be resilient. We don't want it to fail and fall on its face just for nothing. But then it's a lot of the same things that we have done before, and we kind of sometimes ignored before, right? So we had these things of SQL injections, right? Now you can do prompt injections. You can ask in a prompt to do some horrible things, or like ignore all the previous instructions, do something else, right? There is an OWASP list for AI. If you haven't seen that, have a look at this, like for AI applications. You should validate both output and input of stuff going in and out, and then you can actually do it with the code, through the code. Fallback mechanisms. If something fails, if something taking too long time, what do you do? How do you just let it spin, or you fail over to something that's not AI, or fail over to something standard? It might be a good idea to think about those kind of things. Very important part here as well is the fairness and bias and all those things that have to do with ethics and correct and fair AI. We've had that for a while. We talked about this for a while. It doesn't get less important. It's still a very important thing. Very important to also monitor and log, because your users will be creative. They will make it do some weird stuff. You want to be able to see those kind of things and maybe fix it. Rate limiting, error handling, all these kind of things, they still apply. You still have to do that. You don't want to your systems get basically DDoSed because somebody asked to print the first 300,000 million billion characters of pi, right? It will do it. If you ask it, it will just go. If there is no limits on the model, right? You want to be able to handle those kind of cases as well. It goes a little bit together with the prompt engineering best practices. There is a list. We don't have time for this, but have a look at that. Have a look at OWASP top 10 for AI models and all those kind of things. It's as important as it's always have been for other things with security, with SQL, with cross-domain scripting, all those kind of things. When it comes to Java, there are a bunch of libraries, but I want to kind of bring up two that are the most common ones or the most talked about right now. It's Spring AI, and it's LangChain4j. So LangChain4j has been supported by a lot of movement, a lot of people doing open source contributions and everything. And at some point, a lot of people in the industry picked it up, like Red Hat and IBM people that have been contributing a lot, writing a lot of libraries and stuff and additions to it, and implementing it in Quarkus, for example. And now talking to an LLM through Java code is not more than just a few lines of code and a little config, because they've done all the fun things for you. This is a bit of a reiteration of what we talked about and what you can think about when you create your own applications. Your applications can run on local LLMs and open weight models. You can also do orchestrations with agents, function calling, also agent to agent. So A2A protocol is pretty cool and interesting to have a look at. Your model is as good as your context that you're providing. Context can be also local. You can do it through embeddings and stuff like that as well. RAG. It's been talked quite a lot as a silver bullet to everything. Now the focus is shifting a bit, but it still is very, very central part of making things work. Data transformation and structure, you can also ask it to do that. Be careful with hallucinations here. It can be an issue, as everywhere else, but here it's a bit more important, because when you're transforming some data into something else and it just hallucinates some stuff, might not be a good option. But sometimes it's actually very useful, especially for generating test data. That's actually very, like, if they're good at something, it's generating like fake synthetic data. That's really, really nice. A use case for that. And well, yeah, resilient applications, make sure that it actually works. We still have a few minutes. We can do the questions, and I can also show you a quick demo just to see how it works locally and a little bit of a performance. You can find me on all kind of social media on that site. So if you go to rustam.no, you will see all the social. I got tired of putting everything, the next thing that's going to kill Twitter, and there was like a list on my last slide. Everything is there. Pick the one you want and try to you will find me there. So a quick demo. So it's like a very, very quick demo. We still have 10 minutes.
Yeah.
Okay.
Let's see if we can fix the flickering.
Oh yeah, flickering would be nice to fix. Okay, we can do questions while we're trying to fix the flickering.
Yeah.
Any questions? Any comments? Thoughts?
Any questions to Rustam while we try to fix the flickering? So, have you built any AI-infused applications that you run in production?
Yes and no. I'm working now on running an. Still flickering. So I'm working now on a system that will get into production soon, not necessarily at work, but it's a part of some research stuff I'm doing. But that's where we're using also LLMs and function calling to map data between different data sources and try to understand how things are connected. So I do have some of that stuff, but it's not. Right now, it's been published as an articles, but implementation is not public yet.
Okay, I have a question. About a year ago, I tried running a local LLM using Ollama. Yeah. Is that still the way to go with Ollama? Or?
You can do that. I mean, that's what.
Or are better alternatives?
There are a few other options as well. We'll get the picture soon, I guess. But I do, like, in this demo, in this case, not yet. In this case, I actually still run Ollama, but there are a few others. There are a few other open source interfaces where you can run LLMs locally. But Ollama is very nice, and most of them are very similar in the sense that it will run it locally, but still give you a simple API so you can talk to it. Okay. Yeah, because those systems don't do much, really. They wrap around and they create an API for you, and then I also have a way to download and manage those models for you as well, which is really nice. In most of the cases, you will use something like that, yes. Yeah, it's the same. Yeah, it is. But it's okay. I mean, we can.
Should we try it? And I will.
We can try.
Yeah.
Do or do not.
Any other questions for Rustam? All right.
Okay.
One more time.
So now we'll get the picture soon back. So in my demo, like I said, there is you see there is Ollama there, and it's running a model here. It has a bunch of different models. But the cool thing is that, so right now I have set up, where is my properties file? Here it is. So I've set up for it to run with Gemma 12b. I'm getting very language confused. But 12b is the model that I have here. So the funny thing is that that's a really kind of nice thing, but also can be a bit of a performance hog. So if I'm compiling the Quarkus thing, it will just boot up and say everything is fine, right? But it has also default values. So it was not planned to show you as a demo, but since you asked about those managers, I can talk a little bit about that. So if I just commented out, well, that's not a comment. What language is this? Oh. There. So what will happen now at some point, it will actually start downloading see what it says there? It's downloading Ollama. And that's because I don't have that model, and it has Ollama model as a default. So now it will try to download it before it actually starts. It does a lot of management for me. It's gray on gray, so you cannot, on this screen you cannot see it. Actually, it says downloading and Llama 3.2. And the progress is also in percentage, but it's also gray on gray. So 35%. But anyway. Let's go back to Gemma. So I'm running Gemma 3, 12b. It's also running locally on my machine. And the good thing is that you can implement, so for users, it will be kind of invisible because, again, this is a kind of older hardware I'm running on, so it will be a little bit visible because of the performance. But apart from that, it just works. So I have a very simple greeting method in Quarkus that has nothing to do with AI. You just provide something, and just your return, it will return the value, whatever you provided there, right? But I also have things like, if you hide that, still have 4 minutes. So this is my API stuff that I have, right? So this is the greeting and a name that we had that has nothing to do with AI, it just returns you a string. I also have a poem which uses my AI service and writes the poems about computer science with 4 lines of code. I also have a poem on a topic that's whatever you want, and it still sends that topic name to the function and does that for me. And you have a few other things there as well. The interesting part here is that if you go to write a poem, What it does, it has two things. It has a system message, so system prompt and user prompt, which is a bit more generic context for a model, and also the specific task, what to do. And that's it. So there is no more code than this, right? You just have some messages that you provide, and then if you go to here and do a poem, yeah, greeting. Sorry, hello poem. Yeah, sure. I mean, it's poetic, I guess. With logic's grace and digital design, blah, 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 right? But then you can also give me a topic. Well, it suggests biology. You want something else? Oh, this is interesting. Cloud, native. That was not a Freudian slip. It actually worked. Continuous improvement in the digital space, microservices dance a fluid pace, cloud native thrives in pacing changes, embrace. Okay, you know. I mean, it's not Shakespeare, but the cool thing is that it's actually running now on my machine, and you see there is a little bit of a latency, a little bit of spinner when I refresh, but it's actually pretty fast. And you can do things where you provide variables to it, right? So you can, if we go back to my resource, which, this demo took 5 minutes to build, right? And then, but the cool thing is that you can actually build a demo like this in 5 minutes. And also you can do variables. So you provide a variable here, you provide a variable, you take the variable here as a normal you would do in a REST service, and then it is being used for other things. So you can do random strings is another option. I know we're out of time, but we still have 50 seconds, so it's good. So it's supposed to give me, this is about returning structured data, right? So now it's actually returning me a JSON. And I told it to return the JSON, so it's not just the text and haha. No, it's actually structured stuff. But the cool thing is that I actually have a function here with language, so I can do Bokkefjell. That's just because we're in Bergen. Let's see what happens. But this is how simple you can do stuff without writing much code. So that's a kind of a bit of a teaser that you can do that. Don't do that for this kind of simple things, but it's just to show you how easy it is to write with. So this is running with Quarkus with the LangChain4j, just Java, and on this machine, and I'm still not hearing the fans go off. So it kind of works.